Hello again with Just Math. Uh, in this video, we're gonna discuss problem number 5 from Baby Rudin Principle of Analysis. Chapter 1, Problem 5. Let A be a non-empty set of real numbers which is bounded below. So A is bounded below. Let minus A be, by definition, be the set of all numbers minus x. So consists of the negative of all elements in A. The minus of all elements in A. The x in A. Prove that the infimum of A is equal to the minus of supremum of minus A. Okay. So we will think of this into two steps. So the first one is you want to see the statement as this, and the second one, after we multiplying both sides with -1, we will have minus infimum A is equal to okay, so these two statements are equivalent, I would say, right? So if we want to show the given statement, then we can prove any of these two statements, right? But the reason why I split this into two equations is because I want to emphasize on the property of whether it is infimum on the left hand side or whether it is a supremum on the right hand side, right? Okay, so maybe this one is just should write this on the sketch paper, right? Do not include this in the neat argument that we will present later. Okay, so in order to compare the left hand side and the right hand side, we need to somehow show that this guy on the right hand side is also a lower bound for A, right? Remember that the infimum of A is the greatest lower bound. So if this right hand side is also a lower bound, then we can somehow compare. Okay, so let's see. By definition of supremum minus A, okay, the supremum of minus A so by definition this guy is the supremum of minus A is bigger than any elements of minus A. But every element of minus A can be written as minus x. So for all x in A, we have this. After we are multiplying both sides with -1, then we have x is bigger or equal to this. And this holds true for all x in A. So this tells us that the supremum of I should put negative. Minus supremum of minus A. So this guy is smaller than all elements of A. Hence, minus sub of minus A is a lower bound of A. And then by definition of infimum, which one is bigger? The minus supremum of minus A or the infimum? Remember that infimum of A is the greatest lower bound. So if we have another lower bound, then that lower bound should be smaller. We have minus 2 minus a is less or equal to the increment of a. And we are hoping to get the other inequality from the right hand side. Okay? So, like I said before, that on the right hand side, we want to focus on the property of being a supremum. And in order to be able to compare with this supremum, we need to show that this guy is also an upper bound, right? So, okay, then we start with the infimum. By definition of infimum A, for all x in A, infimum of A is less or equal to x. And then after we multiply with negative 1, minus infimum of A is bigger than minus x. And this holds true for all x in A. So this tells us that then minus infimum of A is a lower bound. It's an upper bound, actually. It's an upper bound for all elements of this form. But the set of all elements in the form minus x is minus a. It's an upper bound of minus a. Okay? Now, by definition of supremum minus a, this supremum minus a is the smallest upper bound. It's the lowest upper bound, right? So if we have another upper bound, that upper bound must be greater or equal. So when we have supremum of minus a is less or equal to minus infimum of a. Upon multiplying with negative 1, we have minus sup of minus a is bigger or equal to infimum of a. Okay. So now we have a pair of inequality, and the first one saying that the left hand side, is too thick. So in the left hand side, in the left column, we have that the left is less or equal to the right. Meanwhile, on the right hand side, it says that the left is greater or equal to the right hand side. And that can only be true. Both sides can be hold true if the left and the right hand side are equal. For minus supremum of minus a is exactly infimum. And we are done. So again, thank you for watching. Don't forget to subscribe and press the like button. See you again on the next video. Bye bye.